So in this video, we're going to demonstrate how to build a unit circle, um, particularly with the coordinates in the first quadrant of that unit circle. So I really like this image because it's really clean and it gets straight to the point as to how and what you're going to do. So remind ourselves, what is the definition of a unit circle? So let's remind ourselves that a unit circle is a circle that has a radius of 1 unit. Okay, so we're going to start, if we're going to start in quadrant 1, we have to then look at the family of angles, and there's three sets there's three angles, let's just say it that way, that we're going to look at in degrees, and it's going to be starting with 30 degrees. So we're going to look at it from the angle of special right triangles. Okay, now in geometry, which I believe would be the course you would be introduced to the idea of special right triangles, you have a right triangle that would consist of a 30-degree angle, which I will mark in this location. That means that this angle would have to be 60 degrees. In terms of the side lengths of this right triangle, the side that is directly across from the 30-degree angle is considered the shorter leg. Okay, now the length of the shorter leg, we're going to give it a length of 1. Across from the 60-degree angle is the longer leg, and that has a length of square root of 3. Of course, we all know the side across from the right angle is the hypotenuse, the longest side length of the entire right triangle, and we're going to give that a length of 2. Okay, now if you use the Pythagorean theorem, this all would make sense if you square the two sides that you have and set it equal to the hypotenuse squares. This balances out and fares out. So this is pretty much, think of this as a formula. But remember, we are basing this right now off of the 30-degree angle. That's what we're going to focus on in this picture. Okay, the 30-degree angle. Now, here's what I'm going to find from this. If the 30-degree angle is right here in my picture, right? And as you see, I'm looking at the circle. And so this is an image of the triangle that I have here on the left inside of the circle. So this is my 30-degree angle here. What I'm ultimately interested in are the coordinates, the x, y coordinates at 30 degrees. So the way I'm going to find them is through trig, and I'm going to find the cosine of 30 degrees followed by the sine of 30 degrees. So here's what I know. I know that according to the right triangle, cosine is adjacent side over the hypotenuse. So by that measure, it would be the square root of 3 divided by 2. The sine of 30 degrees is the opposite side over the hypotenuse, which would be 1 divided by 2. Now, cosine corresponds to the x coordinate, while sine corresponds to the y coordinate. Okay, because on a unit circle, we typically would associate cosine as the ratio x divided by r, where sine is y divided by r. So with that, my coordinates at 30 degrees would represent square root of 3 over 2, comma 1/2. Okay, so that's the 30-degree angle done. Now, move on down. The next angle we're going to focus in on is the 45-degree angle. Now, the 45-degree angle is right here in the middle of the unit circle. In terms of this triangle we're looking at here, this reference triangle, this can be my 45-degree angle. Since this is clearly 90 degrees, and this is 45 degrees. The measure of the third angle has to also be 45 degrees, because 45 plus 45 is 90, plus another 90 makes 180, the total sum of all three angles. Now, it just so happens this triangle is unique and special because the angles are equal. So this plays off of, in geometry, you learned about isosceles triangles. And you might recall isosceles triangles have two sides that are congruent. So that would mean that the opposite sides of these 45-degree angles would have the same length. Okay? Which is great, because if we assign it, let's say, a length of 1, then we can figure out the hypotenuse hopefully pretty easily at this point, right? Because if we take 1 squared plus 1 squared and set it equal to the hypotenuse squared, then that means we get the hypotenuse is going to be the square root of 2. Okay, now that we have that, here's our goal for this image. For the 45-degree angle, I want the coordinates there. Notice we're still in quadrant 1 of the unit circle. So again, we're going to find the cosine of 45 degrees, and we're going to find the sine of 45 degrees. All right, so we remember cosine of 45 degrees puts adjacent side over hypotenuse. However, in math, we've learned when we have fractions and we contain a radical sign in the denominator of a fraction, we must not leave it there. We must simplify the expression down using a process called rationalizing the denominator. Very long title, but what that means is you're going to then multiply both your numerator and denominator by the radical that's in the denominator, which in this case is the square root of 2. When you multiply both numerator and denominator by that radical, your new ratio becomes the square root of 2 over 2. So that is what we're going to go and define the cosine of 45 degrees as. Now, for the sine of 45 degrees, the opposite side over the hypotenuse is the same ratio, which is excellent for us because we just did the math above, so we know that that too will be the square root of 2 over the square root of 2. Okay, now I have the sine and the cosine of 45 degrees. I can now write the coordinates there. So far we have 2 angles complete and 2 coordinate sets filled in quadrant 1 at 30 degrees, root 3 over 2 1/2, and at 45 degrees, root 2 over 2, root 2 over 2. Okay, last we're going to use the 60-degree angle family. Now, this is good for us because if you recall from the 30-degree family, we talked about 60 degrees in terms of where it was positioned in the figure. So now, in my lower left-hand corner of my right triangle here, I'm going to put 60 degrees, which would mean 30 degrees would be here. Now, if you remember, I labeled the sides by shorter leg, longer leg. Remember, the shorter leg is always directly across from the 30-degree angle, which I labeled 1. The longer leg, which is directly across from the 60, is labeled square root of 3. And then, of course, we labeled the hypotenuse 2. So I'm using that same format. Now I have that labeled. We've already verified that this is a formula for the special right triangle for the 30, 60, 90. Now we're going to find the cosine of 60 degrees and then the sine of 60 degrees. Okay, let's start with cosine. Adjacent over hypotenuse is 1 divided by 2. Let's find sine. Opposite over hypotenuse, square root of 3 over 2. Okay, so if we come over here to our image, we have our ray drawn from the center to the point. Drop the vertical down and make the right triangle image shown. This is my 60-degree mark. So my coordinates here would be 1/2 square root of 3 over 2. Okay, and so that is how you find your coordinates in quadrant 1 on the unit circle based upon your trig ratios of cosine and sine of your reference angles.